స్టార్ట్ చేసేది నేను తీసుకోండి లైట్ ఆన్ చేసేది అట్నే తీసుకుని అటు బాగా చేయాలి కంపల్సరీ అది లైటింగ్ లేదు కదా అట్నే తీసుకుని బ్యాక్ వెళ్ళి అక్కడికి వెళ్ళి డోర్ క్లోజ్ చేసాను పర్లేదు లేదు ఇక్కడ రా వచ్చేయండి వచ్చినాయి ఓకే మనం వాయిస్ వద్దు
టూ పీపుల్ ఒక నిమిషం ఒక లాగిపోయాను అంటే క్లోజ్ చేసేద్దాం ప్లీజ్ లాగ్ చేసేద్దాం విషయం లాగ్ చేస్తాం దాన్ని మాట ఈ లైన్
సార్ good afternoon friends, myself Uday Kumar. I am doing PhD under the guidance of Professor Vaidya Kumar sir. Now I am going to discuss about the demo of the 3D printing process. Right now you can see this is the activity of process which is called laser powder bed fusion. I think you might have heard about laser bed fusion, right? Like what is your suggestion, like your point of view, how it is going process, like basic principle. I'm asking you, like
with the laser the powder is fused.
Yeah, that's a basic principle. Okay, here there are two pistons are there. One we used to call supply piston, another one sintered piston. Okay, so sintered piston it is used to melt the powder, and with the help of the roller it will spread the powder. Okay, right now I'm showing the how it will going to melt here with the help of the laser power. Okay, actually there are four parameters of them mainly. One, I heard about energy density, right? Energy density.
Yes.
Like what?
Energy density basically it's a power per unit volume, with P divided by your laser scan speed multiplied by thickness.
Yeah. So those are parameters. Right now we can't change layer thickness here and laser power. And we can change laser power can change here. Layer thickness you can't change because right now we are following only 30 micron size only. 30 micron layer thickness. And followed by half thickness you can change. And half spacing also. I think like around 75 microns like that. So here in this machine we can make four materials, mainly four materials like aluminium, titanium, cobalt chromium, followed by stainless steel. Okay, right now we are printing stainless steel like 74 pH grade, precipitation hardening steel. Okay, using these parameters we can print like mainly using for intricate shapes, not basic shapes like kind of rectangular blocks, cylindrical blocks. Right now we are printing like lattice structures. I think like previous session Srikanth might told you about the lattice structures.
Yes.
So with the help of M technology only you can print those structures. Okay, right. So four parameters I told you, right? Energy density, layer thickness, followed by laser power and hatch spacing. I think in 3D export we can change the like hatch spacing and hatch pattern. So there are different patterns are there. Like what are those? Like rectangle pattern, like chessboard pattern, like rectangle stripes, followed by hexagon in and out. So we are following hexagon in and out strategy. Why? Because we will take more space and more time to get the like more precise part. Okay. And this is a basic user interface. Right now you can see this is a project which is consisting of like what are the parts used to like print. So observe. So right now I am printing tensile samples using lattice structures. Engage them. Followed by cylindrical coupons. Those are also lattice structures. And this is a printing process like over interface. Like each time the layer will spread, every layer, and laser is going to interact with the powder particles. It is going to fusion, like melting, proper melt. Only powder will melt. And followed by again the roller will spread the next layer. Same like this, stacking of the 2D layers.
Yes.
We can find in the treating component. Okay. See, this is every visualization means every layer how it's going to give like a print. You can observe. See. So these are the tensile samples followed by cylindrical components using lattice structures. These are porous structures. Okay. And after we have to do post processing. Like what are those post processing techniques? Any idea? Without going to short peening, like I need to.
First you have to remove the part, no? Wire radium will do.
Yeah, wire radium. First wire radium you have to do. Okay, followed by if you want to increase surface like roughness or surface improvement, you can do sandblasting kind of thing. Right now we are having wire radium followed by sandblasting. And for basically for lattice structures, some powder particle will going to insert here. You can't able to move. You can't able to remove also. Right now we are like following that ultrasonic gator. Means vibrator kind of thing only. We have to keep the beaker in between the we have to place the lattice structures in the beaker. We have to stir it.
Yeah.
Then somewhat powder particles will go outside. Obviously some particles will go inside like with the attachment of the surface. Those you can't able to remove. Why? Because it is integrated shape right that lattice structures. You can't change that shape. So you can't change this to the shape mostly. So that will be like we have to do either heat treatment also for like heat treatment process. Like kind of to improve the some mechanical properties. Okay. And followed by this is the laser interface. Laser power will be like fiber and laser will be there, which is usually going to melt the that specified area. Yeah, one by one, like come and see the like basic process, like one by one. Mainly the powder is spread the substrate using the roller. So you can observe in the machine right now.
And the specimen is arranged as you told that
Yes.
it will be at
Yes,
some
yes.
degree.
Yeah,
and-
we need to follow that.
Yeah.
Those guidelines we need to follow in setting. Yeah. Otherwise, your pressure will be more if you.
Yes.
So, if it is small parts, it won't be much. But if you have a bigger parts, so the contact area, the contact surface,
Yes, sir.
it should be as minimum as possible. Then you can organize that.
Yeah, thank you. We have an already printed copy.
Printed samples.
Take after.
So while evaluating the like surface hardness of it or roughness of it, so we test it after doing sandblasting or before sandblasting only we do that roughness.
So, yeah, it can be done. As built.
As built also. we can
As
do.
built also, yeah. As built, if you are not satisfied, then you go with the
After sandblasting.
Yes,
then.
yes. So normally we'll get a very good finish, maybe around 15, 10 my area value. Yeah.
That's nice.
So is there a possibility to change the upskin parameters so that C2
Which kind of parameter you want to
upskin parameters? Upskin and downskin parameters.
Upskin, downspin, that is only design part. Huh?
No, actually upskin, downskin parameters so that we can achieve a better surface roughness.
Yeah, that can be done.
We can change that.
Yeah, we can change that. Yeah, we can change that.
So sir, while loading, we are loading it from the front material.
Yeah,
From this.
yeah, this one. Anyway, right now it is, yes, we cannot open it. So we will be loading from here. Oh, so loading will also there. So ఇప్పుడు చేయలేము జనరల్గా ఇక్కడ స్కెల్టన్ గురించి చెప్పొచ్చు కదా.
Okay. In between you have to load the board, right? Actually there are two blow boards are there here. With the help of the blow boards, they have to load the powder.
Yeah.
So using because we can't open the like what is it door. Why? Because in initial innerting atmosphere will be there. If you change the innerting atmosphere, obviously it is going to affect the printed part. So that's why they are giving two gold doors. With the help of the some snake door will be there. Thereby how to keep the powder like metal powder inside.
So normally it will be first we need to do it in the oven.
But
Yeah.
to remove the moisture. Actually.
Yeah, moisture removal. Yeah, then we'll do that one, and then it will be.
And how do you decide the flooding? That you must be doing flooding of the gas no before starting the flame.
Yes, inner thing.
Inner thing, yeah.
Inner thing. Yeah, we have done in the morning that one. we
Okay, okay,
started.
that's
Morning
what
after
we
I
have done.
think I will show you all that.
There, how much like how much pressure you make in the
Actually 6 bar we are meaning pressure. 6 bar pressure.
Okay, yeah.
I think they are the same. SLM
Yeah,
or
yeah, same, sir. 6 bar
6
only.
bar pressure only.
6 bar.
6 bar.
Standard.
Yes, sir.
And for two materials like aluminum and titanium, we have to follow like argon atmosphere.
Yeah.
So I have to use argon gas.
So right now it is a nitrogen gas.
Nitrogen.
So
Because-
for the non-reactive it is nitrogen, like you said, steel, cobalt, chrome.
Okay.
Except aluminum, titanium, we'll use nitrogen gas.
So this machine also comes with nitrogen generator, sir?
Actually, it is a starting model. We don't have a generator, so we are using cylinders. So we'll be changing.
Okay.
Yeah, we'll be switching nitrogen to argon, argon to nitrogen.
This is the final part, okay? So we are going to use lattice structures, I told you, right? But here we are using some like supports.
Yes.
Actually, some lattice structures are there, PPMS, physically. There you can use, you can build without supports also, because it will act as self-supporting nature. So this is the final part, like after white bed. You can show one by one.
Okay. Wire cut, huh? What's up?
Is it aspirin?
Aspirin. After
As-built. As-built only. That's what we didn't remove the substrate also. No, it's as-built. Yeah, we didn't even do any furnace. It's as-built only.
And here we have to remove support structures. So thereby white cut will have a lot of like, trouble also. Because complicated structures, right?
This is a medical implant. Tomorrow I am going to explain one of the case.
Yeah.
Yeah, finish is very nice. This as-built. Yeah, finish means is very, very good.
So are these
Near
optimized
net.
process parameters are
Near net
or
only.
So then you need to do subtractive
Yes,
analysis.
optimization for the
Hybrid only then.
Hybrid
Again,
Yes, sir.
always
Initially we
need
did
to go with.
track
We are going to get only near net shape, but
But I
not.
think the resistance guys give some different performance. Right now we are following.
Yeah, we have a nozzle.
For titanium, we are used by
Transfer adds one more.
because for getting high resistance time after
Yes, yes.
So this is the final part without doing any post processing. Just wire cut.
As built. Yeah, we have removed with the wire cut from the substrate. We have as
So
built.
this much complex we can't able to make it using conventional manufacturing. Using ALM only you can able to print here. That will help you have high like advantage compared to like use other process.
So what is the substrate material? Same substrate.
Yeah, same. They are using same materials, same substrates.
Steel,
Because
steel,
that-
aluminum, titanium, titanium.
What this material?
Steel.
Is steel, right?
Yeah.
316.
Yeah.
Titanium. Plates.
Titanium plates.
Okay, until you finish.
316.
Yeah. After we have to grind substrate.
So is there a possibility to use, say, 306N or any other stainless steel material?
Yeah, we can do it, but we need to develop the parameters.
Yeah, that's what I'm asking. So,
Yes, there is a provision, but these people are very tricky, you know. They sell, commercial people, they sell they will be charging for that.
Okay.
But it is possible. But otherwise also, we can try as a research purpose. And one more threat is, so if it is under warranty,
Yeah,
they may
that-
say that warranty will
directly
void.
say that warranty will be-
Yes.
So that's why I asked, sir. So basically 316N L and 306N are almost very similar in composition.
Correct. Yeah, can you show in the 3D expert maybe some parameters like maybe? Yeah,
Actually, we saw it in the lab session.
in the lab session. The same thing we tried. More or less like trial and error or we conduct, but like they may be having cleverly, they will be selling. So means they have configured this machine with the 4 materials when we purchased.
They have already optimized.
Yes, they'll optimize that and they they supplied that set of parameters. But if you see in the 3D expert, we have plenty of materials. Yeah, we can try. But as I said, like warranty.
Warranty
That
is-
is another issue.
They will not renew the AMC also.
AMC, then you won't cover under AMC. Those
Only
things.
we need to purchase the material from them.
Yeah, but nowadays it's okay. We tried outside materials.
Okay, sir.
It's working. It's working. But if something goes wrong, then they may say that you use some other material like that.
That is there.
But right now we tried with MIM. Indo-MM, we tried Matrix Nano also.
Matrix Nano.
Both are made in India. Made in India, make in India powders.
I know
It's doing good.
Indomie is made in India, so it is exported from Poland, right? Poland or Belgium.
Yeah, maybe that. Yeah, it's injection, metal injection also there. But I think they're claiming that it's a made in India. I don't know. Maybe they might have started here. I'm not sure.
I also heard this.
Made in made in.
Probably it was, for my case, I actually worked on high carbon steel.
Okay.
So probably they imported that material
Right.
specifically, or maybe they produce a few of.
Right.
So what is the base plate heating parameters that is available?
Preheating parameters.
Build plate heating.
Regarding substrate. Yeah, around 80 degrees centigrade is fine for us. Like
So
this machine.
you
Yeah.
have a provision for this?
No, 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 no.
No, we are not preheating. You are asking about preheating the.
So build plate temperature, they
Build
can be
temperature.
maintained at some temperature
I
in
think
EOS
machine
terms.
after going to preheating around 80 degrees.
Automatically
fine
that
for,
will be done.
Yeah, automatically.
So preheating is automatically
Yeah.
by the machine.
No, actually in EOS cases, it will be directly maintained at 200 or
Yeah, yeah.
three-
Yeah, maybe it will. Yeah, depends.
That
Vary
depends upon
from.
the machine and machine.
Yeah, that's what I'm asking. Is there any provision?
No, no,
No, no,
provision,
no, no.
provision right now. Alright, next question.
Okay. So do you have any other questions?
Any queries? Yes.
This was the
No, next lab person.
Yeah.
How we are going to see the board and చెప్తాను చూపించండి ఎట్లా తీసుకో cameraman.
I just hold it.
నేనే పెట్టినా నేనే పెట్టినా సార్ కొంచెం సైజ్
That also you can. Back skinner.
Someone pre-process.
Just keep it. When pre-process.
Okay, I think you might heard about LPQ, right? What is like LPQ? Laser powder purification. Yeah, okay. This is the machine which is sponsored by JDL Systems, DME flexor bed, like direct metal rotated material, flex 100. 100 means build volume. 100 to 100 to 80. And we are using 100 watts laser power. So before going to that, we have to do some pre-processing. Like what is that thing pre-processing means? First of all, we have to load the powder. Before going to load the powder, okay, we have to do first sieving, because the powder particles having 45 micron size, basic one. But the the supplier will spend like will give more like more size. So in order to reduce that part, they have to do first sieving, followed by preheat the powder. Why? Because they have to reduce the moisture content before going to load the inside the machine. So right now we have the silver and followed by.
Always we are using metals. So oxidation is a major concern. So that's what we need to. And not only that, we need to pump the enough gas also. So we have two options. One is the nitrogen. Nitrogen goes with all non-reactive materials like steel, other than aluminum, titanium. So titanium, aluminum, then we need to use argon. So we have two,
Argon atmosphere, right? And we have to load the powder inside the machine. So there are two drop ports are inside. So with the help of the drop ports, we have to load the powder on the supply piston. Actually inside two pistons are there. Supply followed by centering piston. In supply piston, we have to load the powder. Right now, we are already loaded the SSX 316 mix, 74 pH steel. Okay. And apart from that, first of all, we have to load the part, which is the WAP3 file, application file. I think in the previous session they might told you about the 3 types of software. In the software, we have to design the specified part and we have to send it to the system. And it will note down that like that what you say kind of codes, G code kind of thing. Then based on that codes, it will follow the centric process. Means layer by layer upon. So by stacking about the 2D layers, we'll get the 3D component, right? So before going to 3D component, the layers have to melt the powder particles. I think you already seen some videos regarding how the laser is going to melt the powder particles in between. Okay?
Before lunch,
Yeah, before lunch I already showed you that single layering centric process. One layer spread followed by centric process and followed by the roller will spread the powder again. Second layer.
What is the thickness? You are controlling the thickness of the powder?
Yes sir, right now actually 45 microns will be the powder particle size, but layer thickness will be around 30 microns. So up to 30 microns you have to melt the powder.
layer thickness is nothing but your Z movement of the build platform. Yes.
So that thickness we can vary also.
Yeah, we can vary, but right now we fixed it actually. So we can vary, but all are uniform thickness. But you cannot vary in between. So once first layer to the last layer, so always it may be either 100 micron or maybe 50 micron. It is fixed, but you have a range.
You can have to change the powder also. Yeah,
Yes.
obviously.
You can bring that. Curved means then you curve in a number of layers. Yes.
Stacking of 2D layers will get 3D component. If you having some overhangs, if you give curvature, it will going to reduce the overhangs, support structures. So that's why you have to use some lattice structures. I think entomology also he might told you about the lattice structures to reduce the supporting structures.
Powder itself is a supporting material for it.
Yeah. But up to somewhat limit. If you have an overhang up to 90 degrees, you can't able to print the part of the powder. I think my professor already taught you regarding the overhang.
First session,
Yeah.
design for a
And followed by
Do you have any questions? Any questions so far?
Latest penetration depth also it's 30 minutes.
Depth of penetration. Yeah, obviously like which we are targeting. Yeah, so one layer, but sometimes it may go. I can understand your question. Like say, yeah, so that's what even the professor, the expert also telling in the modeling also how simulation modeling also how we can. Yeah, obviously it may be. Sometimes it will be over melting, or maybe melting the previous layer also. Exactly, yeah.
so before that they have to do some remelting initial layers. Why? Because substrate will be there, right? Substrate, same material, same substrate, right? They have to attach the substrate. That's why we are doing double remelting. Or else if you do single melting, like it will get the distorted. So in order to reduce that one, you have to do initial 5 to 10 layers double centrifuge will preferable actually. We are following the same pattern here. After that, based on the some defects will be there, like rotor accessor will come. Then they have to stop the machine, and there will be one advantage will be there. You can resume the print even after 2 or 3 days also. After rectifying the problem. Like suppose if we get rotor accessor,
Yeah, in my design for AN class, I told you like how you can organize these. So you should not put like say your roller and the part. If you try to minimize the contact area between the roller and the workpiece, that's what you are maintaining from 45-degree angle. So we need to follow all that guidelines. So otherwise sometimes it will give you like error also. Yeah, so then you must be thorough in those design guidelines.
Defect guidelines.
But again, sir, quality order support is there all around the material. Then also helps to become. In case of the injury.
No, actually here the support is also same material. We don't have a choice here. It's also steel. Yeah, support sometimes it will be acting as a conductor also. If you are not giving a support, what is going to happen? Where this heat will be dissipated. It won't dissipate heat. So that's what the support will acting you as a conducting medium also sometimes. So then, yeah, in that way. Otherwise, if you are not giving supports, so you have a huge heat.
Kind of delamination.
Yeah, delamination will come.
Distortion, mostly.
But again, for providing the support also it is a difficult task.
So you have to remove that. Yeah, removing
Post
the
processing will
supports.
get more time to remove the support.
But and we are not in the hurry to minimize or remove the supports, so it will lead to the thermal problems. But the thing is, yeah, I can understand the supports. Yeah, we need to put more effort during the post processing. Yes. So
And one solution is like not to remove the supports, they have to give some lattice structures kind of thing, which is having high surface area to flow the heat. That's another solution for
So
the
it is a layer by layer process. So support also at the same time their height should also increase with that component.
no, at a time we are making only one layer, na? So let it be whether it is a model or support. Say if you take a particular cross section, at that particular cross section, it is a combination of model as well as support. But it's the same material, same temperature you are operating it.
I think they might talk about the couple ratings, I think like.
No, actually carrying the support now because it's a layer by layer process.
Right.
One component will make for example 100 number of layers. So support also initially the support their height will be less and the support height should also increase at the same time. So you will be providing the support to the structure.
I think it's just supports last minute. So these are supports.
See, all these layers are supports.
These are
See,
you can change the supports also. If you not reduce the post processing time.
So initially we have made the support.
Yes,
and
yeah.
after that actually. So now it's
yes, yeah. Now you can pause on. So this is substrate and substrate is printed. Melted. It's melting only. It's not centering, it's melting.
Like kind of fusion, you can say.
No. It's melting. There is a slight difference, but it is melting.
Actually, a lot of names will be there. DML is like.
Yeah, then always there will be a loose powder. We need to blast it or we need to.
So this is the final part after doing post processing. Without supports, you got printed. This much complex, you can't able to print using normal conventional manufacturing techniques. Using AM will be preferable actually. That to here.
No, there will be two kinds of melting. One is partial melting, another one is full melting.
Full melting.
So it will come under full melting. Partial melting is again that is centering. Sometimes we need to have binder also. We need to do debinding it and finally furnace treatment. Finally, you will get 100% done. But here there won't be any furnace treatment. It is full melting technique. We are not doing any post processing in order to improve the density. It is a full melting process. But centering, we need to do some furnace treatment in order to get 100% density.
Mostly
That is the
for
difference.
polymer settings.
Even metals also, some
Like kind of binders, yeah.
yeah, binder, they will mix with the powder, but it's a full melting process.
Apart from the new poetics, like,
They can see that layering also.
you can observe one by one layering.
This is a layer, it is a very thin simulation product. Layer. So, layer కూడా చెప్పండి. Right now it is 21 layer is going on. We have totally 434 layers. Yes, see, that name people but we have SLS, probably you might have heard about selective laser sintering. So that was the Carl Decker patent on that. But then people started melting technique. But still the name is carrying sintering. But it is not sintering actually, it is melting. But SLS, that is sintering, which we need to do some furnace treatment. But the name is carrying on still with the sintering. But it is not sintering, it is 100% melting. But the name, maybe the DHA, the word sintering is coming. Like you take this, how much powder will you use? So I need to print this. How much powder I take? Yes. As it is, I want to print how much quantity of powder I need to. So whatever it is. Yeah, steel, maybe steel. For example, it's this is what you tell.
It's around 10 kg.
10 kg. 10 kg steel is not a costly, but 10 kg titanium it is very costly.
But again, we have mistakes, right?
Yeah, then we can even reduce the quantity of the
It
titanium.
around takes around 5 to 6 kg. And
Yeah, 5 to 6 kg titanium.
then you have to follow like layer, right? Water volume. Next will be mass by volume, right? If you want to get for mass, either you have one next will be volume. Here volume will be suppose 100 to 100 kg. Next will be component. Then you can get the mass, like how much quantity you have. Here you can get for example, it's not total, right? But you can't show it there. After this one, right? You can get like
Earlier I
then you have to go about the base of the and still depends upon the layers of
So right now it is 434 layers. Right now it is 21 layers. 21st layer it is doing. Totally we have 434 layers. And just for the demonstration purpose, we didn't remove from the substrate. So which you can see there are the supports. Now you do with the wire cut. Do you have any question?
any queries?
So this as built, this is the surface finish which you are going to get. further we can do any post processing, like sand blasting. We can do whatever post processing.
ఫస్ట్ వన్ ఇవ్వమంటారు
ఇంకో బ్యాచ్ అయిపోయి అన్ని బ్యాచెస్ అయిపోయాయి.
ఇంకా వస్తారు సార్ మనకి వాళ్ళు ఉద్యోగాలు వస్తారు ఇంకా మన బ్యాచ్ 20 వచ్చారు ఇంకో 20 వస్తాడు పోస్ట్
పోస్ట్ processing. రేట్ వెళ్తుందా మరి కెమెరా అక్కడ డోర్ దాకా వెళ్తుందా చూసుకో. ఎక్కడ దాకా వెళ్తుందో చూసి జాగ్రత్త జాగ్రత్త. టేక్ కేర్. అంతేనా అది పట్టుకో. ఎక్కడ పెట్టుకోండి కింద పెట్టండి జాగ్రత్త దాన్ని కలపకండి. ఆ వైట్ కలపకండి మరి మంచిగా
ఓకే మెషిన్
అక్కడ తీసుకోండి. ఇంగ్లీష్ పెట్టుకోండి నేను కలపకండి.
2 కోట్ల మెషిన్ వచ్చేసి మార్జిన్ అర్థమైందా ఓకే అది తీసుకుందాం
అది కూడా చూపిస్తే బెటర్. మెషిన్స్ కూడా ఒకసారి అవి తీసుకుంటే తీసుకున్నారు ఆయన చెప్పేటప్పుడు కూడా ఒకసారి
process you have to remove the drill substrate and followed by removing the wire cut area. Using wire cut area we have to remove the part. Where is the part? నా పార్ట్ తగ్గరా పార్ట్
టెక్నికల్
ready. So this is the final part, right? After cutting from wire iridium, we can get this part. Suppose let's example, and you have to do some heat treatment process. Right now we are having muffled furnace. So after keeping inside the muffled furnace, either you have to do heat treatment or anything kind of thing to increase the proper mechanical properties finally. And after that, you have to increase the surface roughness or improve the surface treatment. You have to follow the sand blasting, or you used to call it short peening. Different names will be there, but process will be the different same process. Like sand blasting, like the sand particles will spread down the surface. It will have some impact. So this much pressure it will have like in 45 bars I think so. This much pressure you can use, but depends upon the application point of view. Okay, and mostly apart from that, one machine will be the ultrasonicator. I told you initially, ultrasonicator. This ultrasonicator. See, this is a glass breaker. So you have to keep the part inside here and fill it with ethanol. Followed by you have to keep inside here directly. Then after the vibration, the powder particles which are attached to the surface, cleaning. Yeah, kind of cleaning only. Because in order to remove the powder particles, it takes more time. And more time. So right now we are using the only ultrasonic for especially these data structures in order to remove the powder particles, like unsintered powder particles or unmelted powder particles. And for suppose surface treatment, I told you initially, like bead blasting will be another point, another application kind of thing. The got my point. Apart from that, any queries?
How do you handle the titanium powder because it is prone to oxidation? So you open atmosphere and
Titanium. You are asking about titanium. Yeah. Right now we are using grade 23, medical grade tech. So in order to reduce the oxidation content, we have to keep in the oven only up to 80 degrees centigrade, and we have to seal it because of course it will easily oxidize. So in order to remove that one, we have to give like
No.
seal.
Opening from the box itself, it can.
That much won't affect.
Okay.
Because initially that in the machine, some preheating will be there. Some around 80 degrees, 90 degrees like that. So that way some current will get reduced. And initial layers we can't able to use that one. That's why I told you have to use some supports or some initial layers to to get the like present part. Not apart from the training.
Don't support like in grade 20. You can buy it here itself in India.
No, actually in India means that orders for supplied by the systems only. Because we purchase from the systems, right? We have to use the same power.
Raw material from the.
We can't use third party materials. If we use, we get some kind of splattering will come, defects will come mostly.
Why? Because in grade 23 is a special alloy.
Yes sir, yes sir.
Grade 5 easily you can get.
Grade 5 industrial purpose, but grade 1 is for medical purpose, that too biomedical.
Underwater also.
Yeah, it is having legal like it's extra. Yeah, anything less oxygen content mostly. And I think I printed some more lattice structures using same grade 23 alloy. Right now we are in development stage of the implant design. So we hope so. Thank you.
Title close up to mission. Title close up to mission. Close up to mission. Title.
Actually, my work is this. So,
Cheer up to better mission.
What titanium we won't use 6 to 8. Purpose parameters we need it. Just specifically 30 microns.
Title, paper, machine. Mood.
But they are suggesting or laser power. That's a full bed from far. More.
Study some, let's say you have some kind of in this and rock in solution rock. Those particles different morphology.
Yeah.
Because I have got some kind of rock in matrix and
Okay. No, but you should.
I can do it.
Okay.
Later I got to know that I have somebody from study something.
Satellite particles. Yeah. But it's great support and everything. Can't get it.
Go back.
Nice. One, the other one. Nice.
సేమ్ కదా ఏంటి లోపల ఇదే కదా ఇదే కదా ఇది చెప్తే వాళ్ళని చెప్తే వాళ్ళకి తీసుకో
తీసుకోవాలి
ఏ కంప్లీట్ తీసుకో
తీసుకోండి Because I more overview. మీకు ఆల్రెడీ మామూలుగా చెప్పినట్టున్నాం ఓల్డ్
So the parallel street is easier. East Coast. So the East Coast is famous for all the all the film industry. Another is the part of the city. Okay. So we have to Annagar, Mayapur, they are all part of the city. So this Asia is almost beach view. So one side it is beach view, other side very one place.
If you try go this side, that side full, you will see that side is right.
So
Yes, sir. I have been. My BTech is from AU. 4 years. Yes. And 2 years I worked for 2.5 years. I worked for material design exhibition. So then it's now. Yeah. So why not the Vietnam? I've never been to AP Alpha because this time this is the first time I am.
yeah, I'm also visiting here for the first time. I'm very pleased to see this machine. Because these are all high-end machines and a lot of photography of them, grants as well. Something useful outcomes, good outcomes. So hopefully it's arriving. Sometime later when I have a concrete plan about the conference, I can please send me the mail. Our university people will also be happy to have a meeting with you. Plan for a conference as a keynote speaker. Thank you, sir. Thank you.
Thank you.
कैमरा
ఎవరైనా వస్తారంటారా? ఎవరైనా వస్తారా?
ఇంకో గంట సరే
అని నెంబర్ 3కి రమ్మన్నారంటే దాని ఒక 45 ఉన్నారంటే
సేమ్ వాళ్ళు ఇది ఎందుకు మనకు లైవ్ చేస్తాను అటువంటి
एक्सपोर्ट अल्ली 3D एक्सपोर्ट ಸಾಕು ಡಿಸೈನಿಂಗ್ ಸ್ಲೈಸಿಂಗ್ ಎಲ್ಲ ಇದನ್ನು ಡಿಸೈನ್ ಮಾಡ್ಕೊಂಡು ಇದನ್ನು ಮಾಡೋದು ನಾವು ಕಂಪ್ಲೀಟ್ ಸಾಫ್ಟ್ವೇರ್ ಡಿಸೈನ್ ಎಷ್ಟು
ಅದೇ ಕಂಟ್ರೋಲರ್ ಬೇಕಲ್ಲ ಜನರಲಿ ಈಚ್ ಮಿಷನ್ ವಿಲ್ ಹ್ಯಾವ್ ಒನ್ ಸಾಫ್ಟ್ವೇರ್ the materials of the ಇದು ಅವುಗಳೇ ಪ್ರಕಾರ
ఇంత పీస్ వాడను హైట్ టోటల్ 3.60 అనేది హైట్ పార్ట్ హైట్ 3.60 లేదు 22 కాదు 13 ఇంచులు 1 ఇంచ్ ఇది పార్ట్ అనుకుంటాను ఇది అర్థంగా ఉన్నాను నేను అర్థంగా డెలిగేట్ కదా ఈ అమ్మాయి ఇప్పుడు ఇంతమంది మంది ఎంతమంది వాళ్ళంతా కాపర్లు ఉంటుంది కదా వాళ్ళు వస్తారు వచ్చినప్పుడు మనం మళ్ళీ పని చేసేది వాళ్ళు వస్తారు ఇదే
ठीक है तो बाकी का
आइडिया
Good afternoon, guys. Myself, Uday. I'm a scholar working under the guidance of Professor Head of the department. So right now, I'm going to discuss the demo of the metal 3D printer using LBBF technology, laser powder bed fusion. I think you might have heard about the basic principle of the laser powder bed fusion. Right? Can you enlighten me? What do you understand? Yeah. Yeah, of course, that is the option. Yeah. And see, first of all, there is two inside. First of all, we have to go into load the powder, right? Before going to load the powder, we have to do some pre-processing techniques. Like, first of all, here mostly the powder particle size will be 45 microns. So, the sender will give like bigger size particles. In order to segregate, we have to do some basic thing like powder sieving. So we have to use 45 micron size powder particle like mesh size. Thereby, only 45 micron size. Above 45 micron size particles will go top. Bottom side will get the below 45 microns. Then you have to melt the powder. Sorry, you have to to remove the moisture. You have to heat up to some content. Then in order to reduce the oxidation, after heating, you have to load the powder here inside. Actually, inside two blow pods will be there. Using the help of the blow pods, you have to load the powder. So there are two main supply pistons, means two pistons, supply followed by center piston. In supply piston, you have to load the powder. So in this machine, we are having four materials: aluminum, titanium, stainless steel, followed by cobalt bromine. Right now, I am already loaded with 74 kg displaced Arctic steel. And last in previous session, Srikanth might talking about some 3D expert design, right? Thereby, you have to do some design using some process parameters like head spacing, scan spacing. You might have to, right? Yeah, layer thickness followed by laser power. And right now, we can't change the layer thickness here. We are calling same default. Why? Because we are taking the powder quantity. We have to take care about the powder particle size also. So, in the medium size, we have to follow 30 microns thickness, followed by scan speed and scan strategy. Those things you can directly change in 3D expert software.
Can you do all four types of orders separately at a time?
No, right
and
now
then
we-
use one of them if you want.
No, we can't do that.
You can't do
We
it.
can't. You have to change the powder. Yeah, change the
Powder
powder.
changing is a big task.
Yeah, big task then, obviously.
And you have to know how to clean.
Yeah. And after designing the 3D expert software, you have to load the design inside the machine. And the part, like what is the powder will spread accordingly, like whatever, like what say layer thickness rate I told you is not 30 microns. So initially listed about to give 70 microns. Right? Because after spreading slowly, the thickness is going to change. Because there will be some bridge will be there, bridge gap. Bridge. Followed by center piston. So the bridge will occupy some space. So ultimately you used to get some 30 to 40 microns. Finally. Then the laser is going to melt the powder. And next layer will spread, laser going to melt. Same thing will happen, but stacking of 2D layers. You will get third 3D component, right? Same thing happened here. And so this is the basic user interface of the machine. You can observe. So total around 434 layers will be there. Right now it's falling on 131 layers. So you can observe this is the place like a display. So these 4 are tensor samples, and these are the cylindrical samples we using lattice structures. Okay, and it will show you the how much estimated powder height. So it depends upon the different powder particles. How you calculate different same quantum density equal to mass by volume, right? You have to calculate the mass and you have to multiply with density. Different materials means titanium different density, steel different density like that. Volume will be 100 into 100 into ATM height. Same thing we have to follow. So based on the calculations, you can get this much height, so this much quantity is required. You have to load the powder like that. Right now we loaded around I think 2 kg, I think so. Why? Because initially some sintering will come. Before going that you have to do some remelting. Why? Because they are using substrate, right? In there, and it should be attached to the part. So in order to some time it is going to detach or it war will come. In order to remove that problem, we are doing remelting, means double times. Then some part will get attached to the surface. So those part we can easily remove wire cut detail. So that is not required. That's why we call them layers mostly.
What is the minimum quantity of powder you should use? Minimum.
Yes, sir.
Minimum quantity. How much quantity of powder?
Powder. It's initially yes, we asked.
Minimum. For example, you don't have that much of quantity of powder.
Yes, sir.
For a material.
Actually, it depends upon the particle height, sir. Suppose they are having particle height of 1 centimeter.
Say particle size 50 to 45 microns.
It will depend upon the part.
What's the minimum? Then put it.
I'm not
I said because I bought a 20 kg of powder or 10 kg of powder. Can you use it? 5 kg of powder.
Actually, basic idea is first of all you have to design the right part, right?
No, not part. It's only some small sample.
How much height? How much height?
Small mini sample will be.
I'm asking height in centimeters.
Maybe 5 mm.
5 mm.
10
Yeah.
by 5 mm.
Yeah.
But what is the minimum quantity of powder that we should use?
Actually, regarding about the calculations like mass into density into volume. Suppose titanium.
These
No,
are
what is the minimum
you
size of the part?
have the dispenser part. If that dispenser will see natural particles that won't be able to use after. Even this question in my previous question, the dispenser is below that level, so we need to have extra water in that. Like dispenser is at the same level as of the built so no problem.
Okay, yes, sir. No.
Actually, like in this machine there is no extra
No
power.
extra water. We have to level the
Like in this bench, well platform and recorder, that dispenser is at the same level.
same level.
Generally for PG, you do large quantities of powder. You don't want to print small samples.
Not that much, sir. Compared to other products, DED kind of thing. It not required that much.
DED is much better. I can put 1.5 kg of powder.
Yeah, DED is how can you say can't you print?
It will, it will depend upon the build platform size. If you are having a build platform 10 by 10, you need to fill it 10 by
100
10.
into 100 into 80. Means 10 centimeters, 10 centimeters, 8 centimeters.
So that is the minimum quantity of
Yeah.
powder.
That's a base build volume. Okay, you're asking about build volume.
No. I'm asking the minimum
Lower
quantity of
quantity of
powder.
Minimum
For
quantity.
example, I say like, I have only 5 kg of powder.
Okay.
I want to put very small samples. Which
Yeah.
consume probably
Like
half
which
kg of powder.
material?
Half kg of powder. Can you do it?
Depends upon the material also. Material density.
Okay, take it again, sir.
Okay.
I'm trying to I just want to get an idea how much minimum
that will again depend the mass of the powder that you have. That will be equal to the total of mass or volume of the powder it can cover.
100 into 80.
Sir, as you are
Depending on the bed space.
so I am saying like just like you are a part of 2 mm, but the build platform is of 10 by 10 and it can go up to maximum 80 as 80.
Yeah, max 80.
So
you have to
if
take
your
about
part,
20.
even though if your part is of 2 mm, but it needs to fill that 10 by 10 volume.
10 by 10 by
2.
2.
So compared to DVD, it will have less.
But their vessel is lot than compared to that.
But here you can't able to print this kind of complex like
It won't be able to possible in
Yeah.
DVD.
I'm not going to argue that. I know what the
No, with the combined turning to do the last layer spreading uniformly, that is a big task. You need the extra powder also.
That's what I'm
That's
asking.
it will
And again-
depend on the recoated speed only.
And again you have to use also. There will be one ratio will be there. One by the ratio.
Complete bread with the spread over the excess powder on
Okay, this is the final part like after doing post processing means by continuing. In the meanwhile you can show like one by one. You can
How much time it will take to print this?
only one sample like height.
For example, this side.
7 to 8 hours. 7 to 8 hours time. Tight and yeah, sir. That one. This one. This one. 738 sir. 735 layers. Tight and but here mostly this for complex structures. And of course, it has small bill volume only. There are different machines will be there like.
But because you are working with powders which are like
Yes, sir.
large quantities, several only calculated for digestion in handling. That's it. Only calculated for it.
Because if build platform size is lower,
Then what's right here? Volume. Volume and density of the somewhat like you can.
That's extra, I don't know.
Okay. Then rough estimation only how to say that actually. We try up to 1500. But you can go for 2 hours also. Yeah. So what's that? Try to maximum 500.
power is better.
And again we are getting 95 watts.
This is 100% utilization confidence.
Yeah.
5% is the
So you heard about that experiments like scans. Most person will just
Here another magic, right?
not that's it.
after this you will show sorting. After this you will show sorting.
Yeah, that's what I told you. You should do it. You should. అక్కడ తీసుకెళ్ళి పోస్ట్ అయిపోయింది ఆఫ్ చేస్తారా ఓకే ఎన్ని క్వైరీ రెడీ దట్ ఈస్
ఇంకో బ్యాచ్ వచ్చినాక అది మార్చాలి అది పెట్టాను
will get some parts which are not moving because it is attached to the surface. Thereby, you have to do some kind of sanitizing or heat treatment. Yeah, right now we don't have that facility, sir. That is also best one. Still, some particles are attached to the surface. We are facing that issue like mechanical post passing. And right now, one of my post colleagues also working on post passing to especially to remove the additive particles.
Partially.
Yeah, partially. Okay.